Welcome back. In our last video, we built the automated engine that calculates and assigns customer tiers, which was a core part of the solution for our client, Bluestone Industrial Components. Now that their internal system is updated, we need to address how it communicates with external applications. BIC is developing a new e-commerce portal, and their web team needs a way to see a customer's tier in real time to show special offers to Platinum members. To make that possible, we need to build a bridge between Dynamics 365 and their portal by creating an API. In Dynamics 365, the standard way to do this is by creating a data entity. A data entity is a versatile tool. We can think of it as a defined window into our Dynamics 365 database where we decide exactly what data is visible. This window works in two primary ways. First, it can be used for bulk data tasks, like exporting a large list of customers using the Data Management Framework or DMF. Second, it can be used for secure real-time lookups via an OData REST API. In this session, we will build one data entity and demonstrate how it accomplishes both tasks. Starting in Visual Studio, we will right-click our project and choose to add a new item. From the list of Dynamics 365 items, under the Data Model category, we will select Data Entity. At the bottom, we will give it a meaningful name, such as BIC, Customer Tier Entity, and then click Add. This action launches the Data Entity wizard, which will guide us through the rest of the setup. The first step is to specify the properties. The most important property here is the primary data source. This is the main table that our entity will be based on, so we will select CustTable, since that's where our core customer data resides. Next, we will update the public entity and the collection name. We will add the company prefix so they're easily identifiable in the future. The staging table already contains the prefix, so we can leave it as is. After confirming these properties, click on Next. In the All Fields section, we need to select the specific fields we want to include in our entity. Here, we will choose only a few key ones for our API, such as account number, customer group, party, sales group, credit max, currency, etc. Once selected, click on Next. Once the wizard completes, if we look at our Solution Explorer, we can see it has automatically added several new items to our project. In addition to the data entity itself, BIC Customer Tier Entity, it has also created a corresponding staging table and security privileges. The staging table is a crucial component for bulk data operations. It acts as a temporary holding area for data during imports and exports that use the data management framework. This approach helps with performance and allows the system to validate data in isolation before it is moved to the final target tables. The security privileges, view and maintain, are also automatically created to provide default, granular security control over who can access the entity's data. Now, if we inspect the new data entity, we can see it includes the standard fields we selected, but it is missing our custom customer tier field. We can add this easily. We will simply expand the CustTable data source within the entity, find our BIC CustTier field, right-click and copy, and finally select the field node and paste it. For this integration, we want the tier to be read only from an external system, so we will set its is read-only property to yes. Because we have now modified the entity by adding a new field, our next step is to update its corresponding staging table to reflect this change. To do this, just right-click and select Update Staging Table. With our changes made, just right-click on the project and select Build. After that, just wait for a few minutes. As you can see, the build has completed successfully. However, a build is not sufficient this time. Because the data entity staging table is a new physical table in the database, we also need to synchronize our project with the database. To illustrate this, I'll just open SQL Server Management Studio. This is the default server, so you can just click Connect. Here, under Databases, we will expand AXDB, select the table and then click the filter icon. Let's enter the staging table name here. As you can see, the staging table is not visible now. A build only creates the definition. So, back in Visual Studio, we will right-click on the project and then click on Synchronize with Database. After a few minutes, data synchronization will be completed. You can then return to SQL Server. Next, with the tables node selected, click the refresh icon. You will now see that the staging table has appeared in our original database. Now, we can see the entity in action, starting with the Data Management Framework. In the left pane, expand the workspaces, then scroll down and select Data Management. A crucial one-time setup step is required here, as the system doesn't automatically know about our new entity. We need to navigate to Framework Parameters, then Entity Settings, and click Refresh Entity List. This adds a quick job to discover all entities. To view the job, we can navigate to the Batch Job page under System Administration and Inquiries. Here, just search for the refresh keyword. You can see the batch job is now executing. Just wait a while, the status will change to Ended. So we will go back to our Data Management workspace and create an export project to get this data out. We'll start by creating a new record and we'll give it a group name, like BIC Customer Tier Export, along with a brief description. The data project operation type should be set to export. Next, in the selected entity section, we will click on Add Entity. This opens a dialog where we configure the export details. For the entity name, we will select our BIC customer tier entity from the drop-down list. We will then set the target data format to Excel. For a simple export like this, we can leave the skip staging option to Yes, which can improve performance as the data is written directly to the file without being held in the staging table first. Once all the setup is done, simply click the Add button. Finally, we will verify all the details and then click the Save button at the top. Once that's done, click the Export button. The batch job is now scheduled. We'll just wait a few minutes for the execution status to change from executing to succeeded. In the entity processing status, the exported count has updated to 32, indicating that 32 records have been exported. Now we can click on the download file icon and the Excel file will be downloaded. Now let's open the Excel file. Let me close the activation wizard. You can see that a total of 32 records have been exported. This is because in the company USMF, we only had 32 customers. Also, the exported columns correspond exactly to the fields we defined for our data entity. Now that the Excel part is done, we will move towards another method through which we can access our data entity, which is by using OData API. It's possible to access the API directly in a browser by taking the Dynamics 365 base URL and appending data followed by the name of the data entity. Hitting enter will return the raw data in JSON format. For a real external application, however, we need a more robust security model. The reason the URL works in our browser is that we are already logged into an active Dynamics 365 session and the browser automatically handles the authentication for us. A real external application, like the e-commerce portal server, which might be running on a completely different network, doesn't have this authenticated session. If that server tried to use this URL, it would be treated as an anonymous request and would be immediately rejected with a 401 unauthorized error. To allow a legitimate external application to securely access our data, we need to set up an application-to-application authentication method. This process involves a few setup steps. We'll start by opening the Azure portal. If you remember, we created an app registration while registering our app in the virtual hard disk for our local environment setup. Now, we will tweak a few things in the previous app. Firstly, under the Manage section, click on API Permissions. Here, we will click Add a Permission. In the Request API Permissions window, choose Dynamics ERP from the list of Microsoft APIs. We are then asked what type of permissions our application requires. Delegated permissions are used when the application acts on behalf of a signed-in user, while application permissions are for services that run in the background. In our setup, under Delegated Permissions, we will add several permissions such as AX, Full Access, Custom Service, Full Access, and OData, Full Access. Under Application Permissions, we will also grant Connector, Full Access. Finally, click on Add Permission button. For a development and demonstration scenario, granting this broad access ensures all potential integration points are open for testing. In a live production environment, however, we would follow the principle of least privilege and only grant the specific permissions that the application absolutely needs to function. After adding the permissions, the final and most important step here is to click Grant Admin Consent, which officially authorizes the application to use these permissions within our organization. With the permissions configured, our next step is to create a secret for our application to use. Under the same Manage section, we will navigate to Certificates and Secrets and click New Client Secret. We'll give it a description and set an expiry duration. Finally, click on the Add button. You can now see a record has been created and it has a value and a secret ID. Make sure to save the value somewhere secure because this key will not be shown again after we leave this screen. At this point, we have the three crucial pieces of information needed for authentication: the application or client ID, the tenant ID, and the client secret we just copied. The final setup step is to return to Dynamics 365 and register our application ID. In the search bar, look for the Microsoft Entra ID application and click on it. Here, we will create a new record. We will copy the original client ID from Azure into the client ID column. You can provide any suitable name, and under User ID, we will select Admin because it will have all privileges. In a production scenario, a dedicated service account user with the minimum required security roles would be used here. Finally, we will click on Save. Basically, by doing this step, we have made sure that if any external request comes only through this particular client, our Dynamics application hosted in our local machine will authorize the request and send the data, else it will just reject it. Now, to test it, we'll use the Postman app. Let's open Postman. In this step, we will break the process into two parts. First, we generate a client token by passing four key values into Postman: the client ID, the client secret, the resource URL for Dynamics, and the grant type. Once the token is returned, we'll use it in our second request, a GET call that retrieves the customer tier data securely from our API. We will now start with a GET request to fetch the API key. The URL for this request is specific to our Azure tenant and follows a defined structure. It begins with login Microsoft Online, followed by our tenant ID and ends with the endpoint OAuth2 token. In the body tab of the request, we will select the form data option. Here, we need to provide 4 key value pairs to prove our application's identity. We will start with the grant type. The value will be client credentials, which is standard for this type of authentication. Next, we will provide our client ID. We will copy it from the app registration page and paste it into the value field. Then we will provide our client secret. We previously copied it to a notepad, so we can copy it from there into the value field. Finally, the last key is resource. This is the base URL of our Dynamics environment, so simply we can copy the link and paste it here. Once everything is in place, click the send button. You can see that we received a successful response. In the body, we can see the access token. We will copy it to our notepad. This temporary access token will be used to fetch data from our Dynamics application. Now we can make the actual data request. We will create a new GET request using our OData URL. We will copy the URL we used earlier to test the OData endpoint from the web browser and paste it into Postman. Under the Authorization tab, we will select Bearer token and paste the temporary access token that we have saved in our notepad. Once done, we can click on the Send button. Let me disable the SSL verification. I'm doing this because our local environment uses a self-signed security certificate which Postman doesn't trust automatically. As you can see, we have received the data from our application, which means the OData integration worked perfectly. If we want to test whether the bearer token actually works, we can remove the token and click the Send button again. As you can see, we get an unauthorized error, which means that without the token we created throughout this process, we would not have been able to access the data. So, to recap, we have successfully built a single data entity that serves as a secure bridge between Dynamics 365 and the outside world. We demonstrated how this single entity can be used for two distinct purposes. First, for bulk data exports using the data management framework, and second, for secure, real-time API access using OData. This fulfills the integration requirement for Bluestone Industrial Components' new e-commerce portal. Thank you for staying till the end. We'll see you in the next session.